This is part 3 of the course. We're changing over now to the final build tool, Gradle. We'll see that this is much newer than Ant and Maven. Gradle takes the best of both those tools and combines them together. Firstly, Gradle uses a proper programming language instead of an XML configuration file. The language is called Groovy. If you know Groovy, then you can do some really advanced stuff. But if you've never seen Groovy, don't worry. They've made it so that you don't even need to know that Groovy exists. Gradle has a concept called tasks, which are different to Ant tasks. So that's a bit confusing, but we'll see how to program tasks in this chapter. And if you want to get a bit clever, you can manipulate Gradle tasks in ways that would be impossible in Ant. Well, we've already covered the big 2 Java build tools, Ant being the oldest of them, certainly the most established build tool in Java, but it is getting really old. Maven is much more sophisticated, but as you've seen, it's also fairly complicated. I think you need a good grip of life cycles and plugins to work with Maven. And as you saw, the POM can get a little bit complicated. Now, Gradle is a much newer build tool, and its general aim, I think, is to copy the best features of both Ant and Maven, but at the same time to add much more power, but whilst keeping the build script as small and simple as possible. Now, it's not as widely used as Maven or Ant, but I hope it's going to become more popular over time. I've used it on a small number of projects so far, and I've really liked what I see. So I've decided to add a section on Gradle to this course, which will kind of make the course feel a little bit more modern than it would do if we just had Ant and Maven. And I hope if you like what you see, you might be recommending this tool as an alternative to Ant or Maven on your projects. Now, I'm going to assume that you're already familiar with Ant and Maven, so I won't repeat any of the concepts from those tools. I'm going to be often comparing Gradle's features with Ant and Maven. So this is going to be a much quicker section of the course because I won't need to repeat all of those basics. As an example, we're going to be using the MVN repository site that we explored back in the Maven part of the course. Right then, the big deal about Gradle is that it doesn't use XML for its configuration. The problem with XML, I think, is that it's really just a collection of tags and values. Now, that might be okay for holding properties or storing information about things, but it's absolutely useless to do any programming with. Well, of course it is. XML is not a programming language. But that's something that you often need when you're defining a build, some way of putting some logic into your build. That's, after all, why we call them build scripts. So let's say you want to repeat a task, I don't know, 5 times. To do that in Ant is really hard because there's no easy way of defining logic and loops. And Maven's the same, really. Maven hides the complexity via those plugins. So if you wanted to do something sophisticated in Maven, like some logic, then you would have to write your own plugin with the logic inside the plugin. Gradle has a completely fresh approach. The build script in Gradle is code. It's a proper first-class programming language. So anything you can do in program code, you can do in a Gradle build. So the Gradle scripts are regular programs, which means we get a lot more power from the scripts. But in Gradle, they haven't used Java as the language for writing the scripts. Instead, they've opted for another language called Groovy. Now, I don't know if you've ever come across Groovy before. It's been around for quite a few years now. And it has a few really interesting features. First of all, it runs on the Java virtual machine. So that means it can interoperate with Java really well. Now, before I talk about Groovy, let me mention that although we're going to be writing our build script in Groovy, we're still building Java code. Our project is still going to be written in Java. Can actually handle lots of different languages. So you might have a project written in C, and Gradle could build that. But of course, we're here for Java, so we'll stick with our Java project. But I kind of wanted to mention that because it can cause confusion. You don't have to go and convert your entire project to be written in Groovy. Another thing is that for most purposes in Gradle, you don't actually have to learn any Groovy programming. And that's because Groovy is really flexible as a language. And what the Gradle people have done is they've taken the language and they've changed it around quite a lot to make it look like we can write build scripts without even realizing we're programming. So, as I say, I don't know if you've done any Groovy, but a little plug here is that my colleague Matt is currently working on a Groovy video training course. So, if you haven't seen Groovy, then sometime in around early 2014, we'll have a really good Groovy course out on the market. Now, as I say, you don't need to learn Groovy in order to write a build script in Gradle. But before we start doing builds, I thought I ought to show you at least a little bit of Groovy. And here is a Groovy program, a very basic hello world type program. And all I'm doing here is I'm setting up a variable called courses. Now, one of the most powerful features of Groovy for me is that you can be very expressive with Groovy. By that, I mean, if you look on the right-hand side of this equals sign, I'm using here some syntax that isn't present in Java at all. The square brackets are telling Groovy that I want to set up a collection. It happens to be a list, and that list is going to store these three initial values. They're just strings, but they could have been objects. So in one line of code, I've been able to set up a collection and populate it with some good values. Notice at the end of the line there's no semicolon. Groovy has decided that semicolons are optional. The next job I'm doing is I'm looping through that list and outputting each of the values in the list. And you do it in a very different way to Java. Instead of using a for loop, I can just take the variable, and there's a method inside every collection in Groovy called each. And what I do to the each method is I pass in as a parameter the code that I want to run for each value inside that collection. Now that does take quite a bit of getting used to, but once you're used to it, you find that it is really a much more efficient way of writing for loops. Inside the curly brackets, all I'm saying here is that I want to print out each element that's accessed in the collection. And this variable called it, spelt IT, just means each individual element in the collection. Well, as I say, please don't panic here. Remember, we don't need to understand Groovy programming in order to write a Gradle build script. But definitely to get more power from Gradle, it might be worth learning Groovy. Before I move on from this Groovy basics, I also want to mention that one of the perhaps surprising features of Groovy is that it's backwards compatible with Java. So if I'd wanted to, I'll just change the caption here, I could have written my Groovy code exactly like this. And of course, as a good Java programmer, you'll recognize that this is all valid Java syntax. It does exactly the same job as my previous caption. I'm declaring an array list, I'm adding in 3 strings, and then I'm looping around that list to output each element in turn. It's the same code, well, apart from the names of the courses that I've added, it's the same code as the previous caption. Now, an experienced Groovy programmer would definitely not want you to write code like this. They'd want to see code like on the previous caption. I'm sure you can see already that the pure Groovy code is a lot smaller and easier to write and read than the Java code. Before we install Gradle and write our first build scripts, I wanted to show you that truly a complete Gradle build script can often be very simple. Here I'm showing you a nearly complete build script. This is a script that would be more than capable of compiling a full Java project. I won't go into the details of it just yet, but I want you to notice that it doesn't look like XML, but it also doesn't really look like program code. I've been talking a lot about how Gradle build scripts are written in Groovy, and what you can see here, believe it or not, is a Groovy program. That's one of the big features of Groovy, that you can twist and bend the language around to make it look completely different from a programming language. So this build script here would be capable of compiling a full Java project. I'll talk about what the apply plugin and default tasks and repositories is shortly. Notice down here at the bottom I have a dependencies list. You'll recognize that from the dependencies that we had in Maven. And the only thing I've missed from this script is the full list of dependencies. There would be a few other dependencies in those curly brackets. So that's why you don't have to learn any Groovy in order to understand Gradle, but that's enough of the introduction. Let's get Gradle installed and start writing a build for ourselves. Inside your practicals and code folder, if you look in the software folder, you'll find I've provided a folder called Gradle-1.7. Now this was the version of Gradle that was current at the time of this recording, and as always on a virtual pair programmers course, I recommend that you use the version that I've provided you. That will make sure that what happens on my video is the same as what happens on your screen. And once you've gone through the course, and you understand how to use Gradle, you could then go to the Gradle website and download whatever version is the most current. So assuming you're going with Gradle 1.7, all you'll have to do there is copy that folder and drop it into the same kind of folder where you have tools such as Ant and Maven. For me on this course, it's been on the C drive, just in the root of the C drive. Now, a lot of people don't like putting apps into the root of the C drive. It is a little messy, but I do that for a small collection of core tools. You might prefer to have it in your program files or wherever you want. And similarly, on a Macintosh or a Linux-based operating system, on a Mac, I put my Gradle folder into the Applications folder, but you really can put it anywhere you like. Now, we could now run Gradle from the command line, assuming that you add the bin directory to your path environment variable. We won't be running Gradle from the command line in this chapter. My plan is that in the very last chapter of the course, I'll return to all three tools, Ant, Maven, and Gradle, and show you them all running under the command line. For these chapters on Gradle, we're going to be running entirely within Eclipse. So now if you switch across to Eclipse, I want you to notice that I'm still working inside my Maven project. And I want to make an important point with Gradle, that Gradle is entirely compatible with Maven. So I'm not going to start a new project, I'm not going to copy this into a new folder, I'm going to work entirely alongside my Maven project. The POM can remain in place, and I could still run the POM if I want to, but I'm going to add a new build alongside that POM. If you need any help in opening this project, refer back to chapter 8 on the course where we first opened this Maven project. Now, how do we run Gradle from within Eclipse? Well, there are two ways of doing this. And the first way, which I'm not going to do on this course, is that if you were to look on the Gradle.org website, in the tooling folder, there is details here under Eclipse about a plugin which is developed by the Spring Source STS team. They're the people behind the Spring framework. Now, according to this provides the best IDE integration so far. Well, actually, I must admit that I've tried to use this plugin now on 2 previous projects, and both times, really, to be honest, we've failed to get it to work in the way that we want it to work. Now, that might be our lack of knowledge about the plugin, but we certainly didn't find it easy. However, I'm not here to criticize the Spring Source team. These plugins tend to get better and better over time. So by the time you watch this video, this may be a viable approach to running Gradle from within Eclipse. So feel free to investigate that option if you're interested. But I'd much rather use the second approach for this course, which is actually trivially simple. If you go into Eclipse, you can simply click on the drop-down list here on the External Tools button. I'll zoom into this area a bit so you can see it more clearly. The External Tools button here is the button with the small toolkit. That's the red blob there. And we used that earlier in the Ant part of the course. If you drop down the list and select External Tools Configuration, you can very easily run Gradle by clicking on the Program link here, and that will make the button here, which is the new launch configuration, it will make that button active. Click on that button. I'll just make this window wider. And what you're looking for is on this main tab here, find the location field, and we're going to browse the file system. And you're just looking for wherever you have installed Gradle. So for me, that was on my C drive, in the Gradle folder, the bin directory. And if you're on Windows, you're going to select the bat file. If you're on anything else, you'll be selecting just the Gradle file. So for me, gradle.bat. And then for working directory, the easiest way to set this up is to click on the Browse Workspace. And all it wants here is in which folder do you have your Gradle build script. So just select the project root. For me, that's Maven project, and click OK. You should see something like this, and then you're done. I'll just move the window up a bit. If you now click on the Run button, let's maximize that console, you should see a Welcome to Gradle and a little bit more information appearing with a Build Successful. If you don't see that, then check that you've copied Gradle into the right folder, check that you've done everything as I've just described. But apart from that, there's really very little that should go wrong here. Well, I'm probably going to get hundreds of support calls now for that, but hopefully you're seeing what I can see. And all we have to do now is write a build script in our project root folder. So it's going to go in the same place where your POM used to go in a Maven project. So we'll right click on the project and select New. Now, because I'm not using any special plugin here, there's no option for a Gradle build file. So you're just going to select a regular file. Now, the name of this file is really important. The default file name is build.gradle. Now, be very careful to type that exactly as you see here. I'm sorry if that sounds patronizing, but if you have even a minor typo, you get quite a confusing error. In fact, in rehearsals, I called this file gradle.build, and I lost about half an hour trying to work out why. Nothing was happening. So it's always build.gradle. When you click Finish, it's not opening in the editor purely because by default, Eclipse doesn't know what a .gradle file is. Actually, on my other monitor, if I just drag this in, you can see it's opened the file in Notepad, which I don't want to use, so I'll close that. You'll need to right-click on the file, select Open With and Text Editor. And now, if I close and reopen, that association has now been remembered. What can we put in here? Well, the first concept to learning Gradle is the concept of a task. Well, we have a bit of a problem here because if you are familiar with Ant, and you should be, then Ant task, remember, is a small job that Ant can do. It's a built-in concept, and you're expected to group together the tasks into targets. But in Gradle, a task is more like an Ant target. Sorry for that confusion, and it does catch me out quite a lot. I want to be clear that a Gradle task is typically a step in your build. So of course we're going to see a task for compiling, a task for deploying to Tomcat, and so on. So this is how you define one of these tasks. We have here the keyword task, followed by the name of the task that we're defining. Now I'll talk in a moment about what these symbols mean. Notice here there's a strange less than symbol that you probably haven't seen in any Java code before. And we've got curly brackets followed by some code. I'll talk about exactly what's going on here in a short while. But for now, I hope you can accept that this is the way that we define a task called hello. But once you're inside the curly brackets, things get interesting. To define the steps involved in carrying out this task, we use any valid Groovy. And remember, because Java is also valid in the Groovy language, you could also add Java code in here as well. Now, this is just a hello world task, so I'm using the Groovy printline statement. Don't worry about that. It's exactly equivalent to the Java system.out.println. And it's as easy as that. So let's go into Eclipse and see if this works. As always, you'll want to follow along with me and do the same in your development environment. So we're going to define a new task called hello. And don't forget these double angle brackets pointing to the left-hand side. They're really crucial, and if you miss those out, you get something subtly different. I'll talk in a bit more detail shortly about what's going on there. But then we have a curly bracket block, and as I mentioned, we can add in here any valid Groovy code. So for now, that's just going to be a print line followed by hello. Now, one minor problem that you might be worried about here is because we don't have a special plugin installed, we're not getting any syntax highlighting here. And in particular, Eclipse is thinking that there's some kind of an error here on the print line. Notice the red squiggly line. Well, actually, all it's saying is this word isn't correctly spelled because it's assuming, as this is just a text document, that we're just writing English in here. So if that does bother you, then you can install the plugin that I mentioned a short while ago. That will give you syntax highlighting, but you can still continue to run the build using this external tools configuration. Now, the code we're writing in here isn't going to be very complex anyway, so I'm more than happy to ignore the fact that all the text is black and a few of the words might have a little red line under them. So that's our first script. Let's see if it runs well. It might not just yet. If you click on the external tools button again, it will remember the last thing you did. You don't have to pull that dialog box up every time you run. But at the moment, if I maximize that, you can see that actually nothing is happening different to last time. And that's because by default, Gradle doesn't know which task to run first. And there are a couple of things we can do here. I'll tell you the sort of unusual way first of all. We could go into the external tools configuration, and in here under arguments we can specify the name of the task we want to run. Well, actually the task was called hello, and if we run now, notice it's now attempting to run the hello task. The first line here preceded by a colon is telling you the task name that's running. And then, of course, the next line is the output from that task. Well, that's a little bit of a pain to have to constantly go into this external tools window every time we want to change the task we're running. So I suggest you pull that window up again and remove that argument from there. We'll go back to the defaults. So now that's running no particular task. And what we can do at the top of our build script is we can specify the default task that we want to run. The syntax is just like this. It's default tasks. Notice that's plural because we can specify more than one of them. And then in quotation marks, these are just single quote marks, we can specify the default task to run. And that's much more elegant because I can now just hit the button. No need for that dialog box. Notice Gradle is a bit slow in starting up. That's a definite weakness of Gradle. We'll probably edit out these pauses on future builds because it will be boring for you to sit there just watching a blank screen, but hopefully the same is happening for you, that we're now getting that task running by default. So as I mentioned, we can have more than one default task in this list at the top. So that gives us our first clue as to how we might sequence tasks together in a build. This is just one way of doing it, and it's certainly not the most elegant way, but we could have a second task, which we could call, I don't know, hello again. It really doesn't matter. Don't forget the angle brackets again. And this time, I'm not very inspired right now. I'm just going to print out and hello a second time. Now, of course, if we run the build again, saving the changes, hello again isn't referenced in the default tasks. So I'm expecting, yeah, we're just seeing the hello task running, but of course we can now just add, following a comma, the name of the second task that we want to run. So if we try that this time, not exciting, but you can now see that both tasks running one after the other. So that's possibly one way that we could sequence a build. However, there is another way of sequencing tasks, and I think this is a better way. If you're familiar with Ant, which you should be, then this will be very familiar because it's the same as Ant. We can specify that for any given task, that task depends upon another task executing first. Let's see how that works. If we go to the hello again task, if we specify in round brackets a parameter called depends on, and notice it's spelled all one word in camel case, that means a capital O for the on, and then a colon, and then in quote marks, the name of the task that this depends upon. So I'm saying here that the hello again task cannot possibly run unless hello runs first. But if I specify in my default tasks that the only one I want to run is the hello again task, then Gradle's going to be clever enough to know that it needs to automatically run this task first. So actually exactly the same way that we work with Ant targets. Let's see if that works. And you can see there that it does. Now this is perhaps a more elegant way of building, and in the Ant part of the course I called it declarative building. In other words, at the top of the script I'm declaring the task that I want in the end, my goal, the final finished job. So I put the finished task right at the bottom, so I'll highlight that. Now this task called finished, you can see depends on two other tasks running first. By the way, this is Groovy syntax, so I won't get too hung up on it, but we've got a square brackets there to specify that we have a collection of tasks to run first. If we have just a single task, we would just put it in quote marks, but for multiples, we use the square brackets. So this will tell Gradle that before it runs finished, it needs to go, if you like, back in the script. First of all, it will try to run do something in the middle. Well, no, there's dependencies here as well. This depends on start process and step 2. Now, luckily, these don't have dependencies, so these can now run. So the first task to run will be start process. Then Gradle will run step 2. That means the dependencies for do something in the middle are now satisfied, and do something in the middle can run. All that remains now is for the finished task. Remember, its dependencies were do something in the middle. Well, that's already run. And step 2, well, that's already run as well as part of do something in the middle. So although step 2 appears twice in the dependencies, it will only run once. So although you're going to find that Gradle feels very much like Maven in the way that it works, in terms of sequencing tasks together, it works very much like Ant. Now I won't bother adding those tasks into this build. Hopefully you get the idea, but of course you can try that for yourself. Just a few things to say before we move on to doing some more realistic builds. I just want to remind you that inside these tasks, the block here in the curly brackets is any Groovy code. So for example, you could do a loop here. Well, I don't know if you know any Groovy, and I'm not a particular Groovy expert either, but just in case you're interested, for example, a loop in Groovy looks something like this. We can say for dot times, and then curly brackets, and inside the curly bracket, the thing that we want to execute 4 times over. What I love about Groovy is that often the Groovy is very, very readable. So, I'm almost literally saying 4 times I want to print out. Let's say I just want to print out the first 4 integers. We can access a special variable called IT, which effectively means the loop counter. Obviously, this is useless for a build until you do something interesting inside there. This is really just any code you like. So there is 0, 1, 2, 3. Now, even if you don't know any Groovy, remember that all Java code is valid Groovy. So if you're really stuck, you could always use regular Java. So I'll do a normal for loop from 0 up to, I don't know, 10. Well, I hope you're very bored at this stage. This is very dull Java. Let's do something slightly more interesting. A java.util.date as a new instance of java.util.date. And I'm just going to print out the date and time as of now. Now, if you're a Groovy programmer and you're watching this, you'll be absolutely disgusted because you can do that very much more cleanly in regular Groovy. But I just wanted to show you that, well, in normal Java, we would have system.out.println. So that will output the current date and time 10 times over. Goodness knows what the use of that is. But at least it serves to prove a point. That was normal Java and it worked. And it would look fairly ugly, but we could put an import here at the top of the script to import java.util, and we could remove the java.utils from there. Okay, that's still running. Well, if you know Groovy, you'll know that java.util is automatically imported anyway, so I didn't need this line. But just once more, serves to prove the point that this isn't a configuration file that we're writing. This is a proper program code. So I'm going to remove this because I was just demonstrating there. Now, in a few moments, I'm going to move on to show you how to start writing a real build. But before I do that, I'm going to play around a little bit and do some slightly more advanced things. And my aim here really isn't to make you an expert in Gradle, but just to give you a hint as to the power that you can achieve. You might find it a little bit overwhelming. Feel free to skip these next few minutes if you're not interested and you just want to get started doing building, because these are things that you would do very rarely, but there if you need them. So the first thing I'm going to show you is that although we have now a task called Hello Again, we can add to existing tasks. So, for example, we can say for the Hello Again task, now that's already been declared up here, and I can add in further work. I can, for example, print out something extra, and if you like, you can think of this as an extension of an existing task, because I've taken what was in here and I've added more behavior. We give that a run, and just have a look carefully at the output of Hello Again, and you can see now it's doing both print lines. If you wanted this code to execute at the beginning of the task, then you would delete those angled brackets and add .do first instead. Now for me, that's the difficult thing about working with Gradle, remembering the little quirks of syntax. And even in rehearsals for this course, I accidentally left those angled brackets in there, and that just will not work. It can be quite confusing, that. But that will force this extra line of code to happen at the start of that Hello Again task. So now we've got the extension happening before the original version of Hello Again. So why is that useful? Well, before long, you're going to be given existing tasks that have already been written. And by using this kind of syntax, we can extend those tasks and add our own custom behavior, which is going to be really useful. We can also change the dependencies programmatically. What do I mean by that? Well, let's go for an example. Again, it will be a silly example because we've not got realistic yet, but I'm going to delete this dependency on the Hello Again task. So at present, when we run, we're just going to see Hello Again running. But we can add a dependency down here in the, if you like, in the main part of the script. We can do this programmatically by simply saying that for Hello Again, and we want to add a dependency, so we use that depends on property that so far we've been adding in the brackets here, and we can simply pass in the name of the task that we depend on. So that should return us back to how the script was, and it does. We're now getting Hello and Hello Again working. So you might be thinking, well, what's the point of this? Well, the point is that now you can use any logic you like to manipulate your dependencies. So you could do things such as, if there's a configuration property called debug set, then you add a dependency to a particular task. You could even do things like, if the build is happening at night, then we're going to add a dependency on the integration tests. But if the build is run during the day, we don't want to run the integration tests because the integration tests are too slow, and really the sky's the limit. So I'll just illustrate that by adding in a bit of logic here. I could say, well, I'm going to do something silly. I'm going to say, if math.random, which you might know generates a random number between 0 and 1, and I'm going to say if that random number is less than 0.5, then we're going to add in that dependency. Otherwise, we won't add in the dependency. So that means half the time the dependency of hello will be added, half the time it won't. So this time around it was. This time around it wasn't. And again it wasn't. Well, I could keep pressing that all day, but I hope you get the idea. This line of code here could be any interesting logic that your build depends upon. Now we need to get moving towards something like a realistic build, so I'm going to stop playing around now with these little tasks. But this is a good chance to introduce you to the reference manual. If you go to the Gradle website and follow the link to the documentation, of course the layout might have changed by the time you watch this, but there'll always be documentation, and there's a user guide which very usefully has a single page version. And that means it's really easy to do a Control F in your browser and find anything you need. The kind of stuff we've been doing in the last few minutes, you'll find in Chapter 6 under Build Script Basics, and there's a section there on projects and tasks. And you'll see a few of the interesting things that you can do programmatically in Gradle. And for example, you can see there that they're showing you that you really can do code inside tasks. So feel free to look at the reference manual, and we will keep coming back to the reference manual through the rest of this course. That's the basics of Gradle. Of course, we don't have anything like a build script yet, but I hope I've given you an insight into why Gradle is more capable than Ant. Since a Gradle script is a program script, you can do anything in these scripts that you could do in code. That's something that would be nearly impossible in Ant. We've programmed a couple of Gradle tasks. These are more like targets that you might be familiar with from Ant. The contents of the tasks are just Groovy or indeed Java code. We manipulated those tasks as well. You can change the dependencies on the fly, for example. Now that might not be something that you want to do too often. Well, it depends on what you want from Gradle, but it's great to know that the ability is there. But you're here to build a Java project, so in the next chapter we'll get more realistic, and we'll see how to replicate the builds that we've already done in Ant and Maven. At the end of chapter 15, we'll have deployed our application to Tomcat.